All right, hello everyone. We're going to look at a problem of a wooden raft that we know the dimensions of. We know the density of the wood that the raft is made out of, and we know the density of the water it's in. So not a whole lot of given information here. First thing, does the raft float in water? And explain. Well, for this, the answer obviously is yes, because the density of the raft is less than the density of the fluid. Okay, so anytime the density of an object is less than the density of the fluid it's in, that object is going to float. That's the reason a helium-filled balloon will float in a room filled with air. Air is the fluid, and the helium-filled balloon has a density less than the air. All right, so same idea here. What is the size of the buoyant force acting on the raft? Okay, well, we know that buoyant force is equal to rho times g times v. And you need to remember that rho is the density, not of the object, but of the fluid. And the v is not the volume of the object necessarily. It's the volume of fluid displaced. And that should have gone in the plan section. Sorry about that. And up here, we can draw our raft. And so there's some amount of the raft under the water and some amount of the raft above the water. And so we go to implement this for part B, and we say, all right, well, that's easy. We know the density of the fluid, 1,000 kilograms per cubic meter, times 9.8 times, let's see, the volume of the fluid. Oh, well, we don't know how much of the raft is below the water, and so we can't actually do that. So don't know. All right, so we can't do it that way. Then we go back and we think about, all right, well, what about drawing a free body diagram? We know that there's a buoyant force acting on the raft because it's displacing some water. And we know the raft has weight. So how about if we pick up as the positive y direction, and we use that to try to find the buoyant force. It's going to have a positive value because we're using Newton's second law to find the magnitude. It's going to have units of newtons. All right, so Newton's second law is another chance to be able to solve for this. Buoyant force minus, we don't know the weight of the raft. We don't know the mass of the raft. Oh, but we can find it. Density is equal to mass divided by volume. So if we apply this to the raft, then we can say, okay, trying to find the mass. So the mass of the raft equals the density of the raft times the volume of the raft. So let's see, where do we want to put this? We'll come down here. So the mass of the raft equals 550 kilograms per cubic meter. Oh, I'm off the screen. Here we go. Times, what's the volume of the raft? Well, it's 2 meters times 2 meters times 0.1 meters. So length times width times height. Length and width are both 2 meters, the height 0.1 meters. So now we can calculate the mass, 550 times 2 times 2 times 0.1, and that comes out to 220 kilograms. So we can put that in here, 220 kilograms times 9.8. Okay, there's only two forces acting. The acceleration in the y direction is 0 because it's just sitting there. It's not sinking or floating or rising to the surface. Well, it is floating, but it's not floating up to the surface. So it's not accelerating. And so this way we can find our buoyant force. And it comes out to 2,156 newtons. And we're done with part B. What is the volume of the raft? oh, wait a minute. We can take this and put it into there, and then this volume that we didn't know. Oh, well, we can find the volume of fluid displaced. Oh, this will give us the submerged volume. Okay, so we're supposed to find the volume of the raft and the submerged volume. Okay, so the volume of fluid displaced, 2156 newtons, equals 1,000. All right, so we can easily solve this for the fluid, volume of the fluid, that is. So we just divide by 1,000 and we divide by 9.8. And so we get the volume of the fluid, which equals the volume submerged, which is equal to 0.22 cubic meters. The volume of the raft is, well, we calculated it before, we just didn't write it out specifically, but it's 2 meters times 2 meters times 0.1 meters. And so that's 0.4 cubic meters. All right, so we got that. There's our answers for part C. And finally, what percent of the raft is below the surface? Well, we figured out that 0.22 meters of it is under the water out of a total of 0.4. And then we multiply that by 100 and we get the percent submerged as 55%. There we go. Is it complete? Yes, it is. We answered all 4 parts. The signs of the answer is correct. Well, I actually didn't put these in here, but we expected our volumes to be positive and have units of cubic meters, and our percentage to have a positive value and no units. And let's see. So signs are correct. The units all make sense. The magnitudes, well, the percentage, that part makes sense. It's less than 100. We'd gotten a negative value or a number greater than 100. That would have been bad. So that's a reasonable value. And I think all our other values sort of hard to tell. All right, so we're all done.